Completing the square is something we've already talked about when we talked about quadratic functions. We used completing the square to turn a quadratic function in standard form into one in vertex form. That process also becomes useful when we're solving quadratic equations. So as with all of the other methods, completing the square has its advantages and its disadvantages. Advantage is that no matter what equation you have, this is a completely viable method for solving the quadratic. It will work no matter what quadratic equation you have. The downside is that completing the square can be confusing. It's a very technical process. If things aren't done exactly in the correct order, then the process falls off the rails. However, before we jump into the process, there is one property of square roots we must talk about because this is a major impact with completing the square. If I want to solve this equation that's here, my goal of solving an equation, as always, is to isolate x. So I have x minus 1, that's obviously going to have to get moved. Squared will have to get dealt with, as well as the minus 49. If we're going to deal with this, solving this equation, we would first add 49 to both sides, which would leave us x minus 1 squared equals 49. This is where a new piece comes in. To get the x isolated, again, we need to deal with the minus 1, but that comes second. We need to deal with that exponent of 2. And if you think back to something like the Pythagorean theorem, you would get to a situation where, let's say, b squared equals 16, and you would square root both sides. This is not exactly the same, but it is a very similar situation in which we can square root one side to cancel the exponent of 2. If we do it on one side, we have to do it on the other side. And we would get x minus 1 equals 7. However, that is not completely correct, because in the step above, and I'm just going to lay it out again without the work being done to it, what this step says is that something squared gives 49. And by doing the math and getting to this step, we are saying that the something is 7. And that 7 squared equals 49, which it does. There is, however, one other number that, when squared, is 49, and that is negative 7. We need to deal with the fact that by squaring both sides, we're actually taking into account the positive and the negative value of the number. So the way we do that is back in this previous step here, we actually put, it's called a plus or minus sign with the square root, and that carries through to the next step. To finish solving this equation, this is not add 1 to both sides and get x equals plus or minus 8. That's not what this is. Because plus or minus 7 there is actually a shorthand of saying x minus 1 equals 7 or x minus 1 equals negative 7. Isolating x, we do need to add 1 to both sides on the left. Gives us x equals 8, absolutely. We add 1 to both sides on the right, and we get x equals negative 6. So we do need to remember, after we square root both sides, after we have plus or minus, we do need to split because we will get two different numbers based on what we have. So how does this apply to completing the square? The method is going to be very similar to what we did with quadratic functions. We're going to take the number, the C in this case, move it to the other side. This time I had to add 3. We're going to take the coefficient on x, the 6, like we did before. We're going to divide it by 2. That gives us 3. Just going to throw that in a box for now. Then that 3 that we got, we're going to square it. And that's 9. So that 9 gets added to both sides. And this gets us to a point on the left side where we can factor this. That's the whole design of this process. We need 2 numbers that both multiply to 9 and also add to 6. And because of the nature of completing the square, we have actually made it so that number is the same number repeated. It's 3. So the left factors into x plus 3 and x plus 3. And we'll do the adding on the right. That equals 12. The second purpose of choosing the numbers the way we did is on the left, the factoring, having the same factor twice. X plus 3 times x plus 3 is the same as x plus 3 squared. Which equals 12. And now we're at a similar point to the last example. We have bracket squared. We'll square root both sides to cancel that. We'll add a plus or minus in on the right. And we'll get x plus 3 equals plus or minus the square root of 12, if I go to 2 decimal places, 3.46. At this point, we go and we split. So x plus 3 equals 3.46, and x plus 3 equals negative 3.46. Subtract 3 from both sides. On the left, x equals 0.46. Do the same thing on the right. And we get a second answer of x equals negative 6.46. Moving on. This one, again, we need to get the number, the c, moved over to the other side. We'll add 4 this time. X squared minus 3x equals 4. Completing the square, so we'll take the coefficient on the x, that's negative 3. We will divide that by 2. That is negative 1.5. And I know this being a decimal might create some complications. It does, but nothing we can't deal with. We'll then take that negative 1.5 and we'll square it, which is 2.25. Try a very wide triangle there. That number is what needs to get added to both sides. So we'll have x squared minus 3x plus 2.25 equals 4 plus 2.25. Now this is the point where I'm going to condense and skip a step here. On the left, we need to find 2 numbers that will both multiply to 2.25 and also add to negative 3. We have never factored with decimals involved before, so this complicates things to a point where the traditional method of thinking of numbers that way is pointless. This is why, right here, we have negative 1.5. If you noticed on the last example, the 3, that was the first step of the completing the square, was what factored in here. And in fact, the same thing will happen. So this is actually x minus 1.5 squared. We can just go ahead, straight shortcut to that, knowing what it's going to be from completing the square. That equals, we'll do the math, that is 6.25. We'll square root both sides, cancel off that exponent, and have a plus or minus. On the left, we have x minus 1.5 equals plus or minus. When we do the square root of 6.25, we get a nice, easy 2.5. Take this, split it. So x minus 1.5 equals 2.5, and x minus 1.5 equals negative 2.5. Add 1.5 to both sides. On the left, we have x equals 4. Do the same thing on the right, and we get x equals negative 1. There is really only one more hiccup that I could throw at you, and that's now when we have a coefficient on the x squared, we have an a. We dealt with this dealing with quadratic functions. It'll be the same process again, but no matter what, we have to start by moving this c to the other side. It means minus 5 this time. So 3x squared plus 12x equals negative 5. The next complicating factor is that 3. We need to deal with it. We need to factor it out of the left side. It is common to both terms, and in fact, actually, there's a 3x common to both terms. We will not take the x. That defeats the purpose of the completing the square. We'll just take the 3. We had 3x squared. We factored out a 3. We have x squared left. Plus, we had 12x, we factored out 3, we have 4x left. And that still equals negative 5. Next, we'll go to completing the square. So we'll take the coefficient on the x, that's the 4, whack it in half, we get 2. That 2 we will square, and we get 4. That 4 is what needs to get added to both sides. Inside the bracket on the left, but that is what creates the second complication, because this 4 is technically also multiplied by 3. It is 12 in disguise, so when we add it to the other side, we need to make sure that we have it multiplied by a 3 as well, because it was multiplied by a 3 on the left. So on the left, this 3 can come down. We have x squared plus 4x plus 4 that needs to factor. Well, that's why we look at this 2 here. That will factor into x plus 2 squared. That equals, ends up being negative 5 plus 12, which would be 7. We can't square root both sides yet. We need to divide both sides by 3 because we can only square root when we have a single bracket squared, so we need to deal with this first. Which leaves us x plus 2 squared equals, if we go to a decimal, this would be 2.33, and that's fine for now. Now we can go ahead, square root both sides, cancel that, plus or minus. On the left, we have x plus 2. On the right, we have plus or minus, and the square root of 2.33 is 1.53. As before, do the split. We have x plus 2 equal 1.53 and x plus 2 equal negative 1.53. Subtract 2 from both sides on the left would give us x equals negative 0.47. Subtract 2 from both sides on the right gives us x equals negative 3.53. D is just one more example of that complication, just so we can see it one more time. No matter what, we need to move the c to the other side. That means subtracting 7 this time. Again, we have a 2 as a coefficient on the x squared, so we'll factor that out. We had 2x squared, we factored out 2, we have x squared left over. Minus, we had 6x, we factored a 2, we have 3x left over. Go and complete the square. We take the coefficient of the x, the negative 3, we whack it in half, we get negative 1.5, just like in B. We take negative 1.5, square it, again gives us 2.25. That 2.25 is what gets added to both sides. In the bracket on the left, and on the right, we need to make sure that we multiply it by the 2 that's on that bracket as well. For the next step, this 2 is going to carry down. Inside the bracket, we know because of this minus 1.5, this will factor into x minus 1.5 squared. Equals, we'll skip a step on the math here. 2 times 2.25 is 4.5, and negative 7 plus 4.5 is negative 2.5. Again, we can't square root both sides with that coefficient of 2, so we'll divide both sides by 2 to cancel that. Leaves us at x minus 1.5 squared equals negative 1.25. And now we can square root both sides, plus or minus. We have x minus 1.5 on the left equals plus or minus, and this is where we get the final complication. we cannot take the square root of negative 1.25. We can't take the square root of any negative. So because we get to a point here where the math is not possible to do, this tells us right here that this equation has no solution. We get to a point where the math we're being asked to do is, in fact, impossible. If this had been a question that we had solved by graphing, this would be a parabola that never touched the x-axis.